Okay, now for the next lesson. Just want to check my volume here for a second. Okay, now for the next lesson in our unit on triangles, trigonometry. Beginning on page 105, applying the trigonometric ratios. Now that we know about each ratio, sine, cosine, tangent, we now begin to apply them in different ways. So let's flip over to page 106. Let's begin with a review. You have any right triangle, the long side is always the hypotenuse. Now, depending on what your known angle is, the other sides will be either opposite or adjacent. So here's your known angle that you're going to use. That means side P is opposite and this one is adjacent. This side PQ is adjacent and QR is opposite. It all depends which angle you're working with. And the hypotenuse is always the same. It's always the long side of your triangle. So let's have a look. There's a nice example here on page 106 to get us started. And we want to go ahead and solve this entire triangle using a variety of methods at our disposal. So here I'm going to do a couple of examples on page 106. I'm just going to sketch the triangle that they have there. There's the right angle. This side is 6. This side is 10. And we want to solve this triangle for all of its angles and the one missing side. Let's start with the missing side here. Can use Pythagoras. A squared plus b squared equals c squared. 6 squared 10 squared equals c squared. 6 times 6 is 36. 10 times 10 is 100. 136 when we add them up. Square root of 136. A refresher on where that is. Second key, and then a little square root above the x squared key. 136. 11.66 or 11.6. So our hypotenuse, the long side, is 11.7. Now we're going to solve for one of the angles. Doesn't matter which one. This is the 90. We know this one. Let's solve for this one. So we take this angle here and we can use which ratio? Look at where the known sides are. We can use any of the three sides. I'm going to use 6 and 10. You could use the hypotenuse if you like. I'm choosing to use 6 and 10. So this is the angle I'm trying to find. 6 is opposite and 10 is adjacent. So I am using tangent. Tan inverse 6 over 10. Second, tan 6 divided by 10. 30.96. I'm going to round that up to 31 degrees. 30.96. Round it up to 31 degrees. And to find my very last angle, I'm going to use a very simple method that we've used before. 180 minus 30 minus 90. Minus 31, sorry. 181 minus 31 minus 90 is 59 degrees. All right, let's do another similar triangle right here. this one will have sides of 7 and 11. So a similar problem. Again, we're trying to find the hypotenuse of this one. So let's use Pythagoras again. A squared plus b squared equals c squared. 7 squared add 11 squared equals 49 is 7 times 7. 11 times 11 is 121. We are going to add those two numbers together to get 170. 13.03 is what I get after finding the square root. So I'm going to round it to 13. That decimal is not significant. So now I have my three sides. This time, instead of finding this angle first, I'm going to find this one. So this is the angle I'm trying to find. This time I'm going to use 7 and 13 as my two sides. So there's my known angle. 7 is right beside it, so it's adjacent. 13 is the hypotenuse. Adjacent over hypotenuse indicates the cosine ratio. Cosine inverse 7 over 13. $57.42. So this is sort of in the middle, so we won't round it to a whole number. We'll leave it as 57.4. And then our last step here to find the last angle, 180 minus 90 minus 57.4. $32.6 degrees. Okay. There's a couple more triangles over on page 108. Why don't we do those next? Yeah, let's do those. So essentially, we're combining all three ratios, plus we're using Pythagoras, plus we're using the idea that each triangle adds up to 180 degrees. So let's go with a fresh sheet. So again, I'm sketching a triangle from page 108 with a short side of 5, side A 5, and a known angle of 25 degrees. Well, I'm going to begin by solving for the unknown angle. This guy up top, that's the easiest to do because I already know a 90 and a 25. 180 minus 90 minus 25. And now the unknown sides, I'm going to solve for side B, the middle side. So we have a couple of known angles. I'm going to use the 25 degree angle to solve this. So our known side is opposite of this angle, and the side I'm trying to find is adjacent. So that's opposite over adjacent, that's tangent. Tangent of 25 equals 5 is opposite over x being adjacent. Now, when you have this scenario, you have to divide. 5 divide by tangent of 25 degrees. And let's again show you how to do that. 5 divide by tan 25, 10.7. 10.72. I now have a middle side of 10.7. Side A is 5, side B is 10.7. So to finish off solving my triangle for the hypotenuse, a squared plus b squared equals c squared. 5 squared at 10.7 squared equals c squared. $11.8. That is the long side. 11.8. There's another triangle on page 25, which I will quickly sketch, and we'll do that one as well. And I think that should then be enough examples. So this triangle goes like this. It's got a right angle here. I'm not drawing it exactly the way they've put it there, but we'll work with the one I've drawn. The right angle here, and a 39-degree angle here, and a short side, the shortest side of 9. So again, basically you'll quickly see these are the same procedures. This is the same type of triangle. 180 minus 90 minus 39. Let's see, I think I'll solve for the short side again here. And I'll use this angle. I'll use the 51-degree angle and solve for side B. So, 51. The unknown side is opposite of 51 and the known side is beside it. So we're dealing with opposite over adjacent. Once again, we're going to use tangent. Tangent 51 degrees equals the x is opposite, the known side is adjacent. This time we can multiply because our unknown is on top. Tan of 51 degrees times 9. Let's show that. Tan 51 times 9. 11.1, 11.11. That's fitting for Remembrance Day, is it not? 11.11. A squared plus b squared equals c squared. 9 squared at 11.1 squared equals c squared. 81. 11.1 squared, 103.21, 204.21 when we add them up, and we simply then find our square root. Let's show you that one more time. The square root of 204.21, second, below the x squared key, and then type in 204.21. 14.29 or 14.3. There we have it. Our hypotenuse is 14.3. Let's flip over to page 111. We're really dealing with the 11s today. And give you a few exercises from that page and go over them. Page 111. I'll have you do 4, 6, and 7. 4, 6, 7. Let's have a quick look at those. Similar to what we did for this one, each time you're finding, you don't have to solve the entire triangle for number 4, you're finding the indicated side. So here you're finding side M. They're giving you the hypotenuse for 4A, so that's an indicator that you're using either sine or cosine. The unknown side M is beside the known angle, so that's adjacent, right? So you're going to have cosine 37, x over 5.8 or m over 5.8, doesn't matter. Let's take a look at B as well. We're finding this side here, we have this known angle and this known side. We're trying to find the side across. So this side, the side we're trying to find, side R, is opposite, and the one we know is adjacent. So this time we're using tangent, opposite over adjacent. So you're going to have tangent of 52 and R over 3.7. Yeah, so there's a couple for you right there. 6 is similar to the examples that we did, where you solve the entire triangle, all of the unknown angles, all of the unknown sides. Now look at each of these triangles for number 6. Every time it has a right angle triangle and another known angle. So to find the one missing angle, just subtract the 2 from 180, right? 180 minus 33 minus 90, 180 minus 47 minus 90 for these two. And again, for this one, you'll be able to do the same thing, 180 minus 29 minus 90. Here you're going to have to solve for one of the angles using an inverse of whichever ratio is applicable for C. And of course, then you'll solve for the side. So you'll use trigonometry to find one of the sides, and then you can find your third side with a Pythagoras. A squared plus b squared equals c squared. I would find they're always, if they're giving you the short side, then I would find the middle side and then use Pythagoras to find the hypotenuse. That would be applicable for both A and B. Now for C, you begin with question C, you could use Pythagoras to find your hypotenuse and then go ahead and solve for the two missing angles. D, they're giving you the hypotenuse and a known angle, so I would solve for this angle here, subtracting from 180, and then you'd use trigonometry to find this side and then this side. Or you could find one side, then use Pythagoras to find the other side. 7 is simply a word problem where an architect drew the ramp and you are to find the length of the ramp. You have the height, which is 80, which is your short side. The length of the ramp, a 4-degree angle down here, the length of the ramp is going to be your hypotenuse. How long is the ramp? The slanted ramp, how long is it? Okay, you have an angle, you have a known side. There's also, well, somebody already did this, but you could do 180, subtract 4, subtract 90, and get that there's an 86-degree angle up on top here. So, yeah, solve it that way. Okay, that's it for this recording. So again, you're doing 4, 6, and 7 for your homework.